All right, this is problem number 57 in pre-cal, so I'm just going to title it Trig. We're in section 5.2. This was number 57, which we tried to do in class because it looked so bad. I wanted to try to work it, and then I got stuck. So I got the answer key out so I could see what to do. And here's what I didn't do. On 57, the problem was we were supposed to take negative ln of 1 plus cosine theta, and they wanted us to show that it was equal to a big long expression. And the long expression was on the right side, and I had the brainy idea, which turned out to be not so brainy, to try to start with the more complicated side and turn it into the easier side, which did not go well. And when I looked at the book, they did not do what I did. They started with the negative, the left-hand side. So that's what I'm going to do now. That's what I'm trying to prove. I'm going to use a dark blue here. So what they did is they started with negative ln, 1 plus cosine theta, and then they said, okay, that is equal to ln, and remember if they had the negative out front, that meant that it was an exponent and they had brought it down if we're kind of working backwards. Now that means that we have ln, and what something raised to the negative 1 power does is it flips the fraction. Well, I can make a fraction out of this by putting it over 1, and then if I want to flip the fraction, it ends up being 1 over 1 plus cosine theta, and that pesky little negative is gone now, which is kind of a good thing, because I don't want it in my answer. If you look at that right-hand side up there, I really didn't want that in my answer to begin with. Now, here was something, the book pointed out some examples, and it never occurred to me to go do this. What they do here is they rationalize that denominator. If you notice, I have 1 over 1 plus cosine theta, so they are going to multiply by cosine theta, 1 minus cosine theta over 1 minus cosine theta. So they're rationalizing that. And then what you get is the natural log of 1 minus cosine theta over 1 minus cosine squared theta. And if you think about what that's equal to, you still got 1 minus cosine theta on the top. But on the bottom, sine squared plus cosine squared theta is equal to 1. Remember, that's one of your Pythagorean identities. It's actually the definition of the unit circle. So if I subtracted cosine squared theta from both sides, that would be equal to sine squared theta. So that's what that bottom is actually equal to, and I noticed some of you were kind of giving me a scrunched up face when I talked about that. So let's come up here, and just as a little side note, I want to show you how you can figure this out. Your identity sheet said sine squared theta plus cosine squared theta is equal to 1. And I notice that I have 1 minus cosine squared theta right there. So let me get 1 minus cosine squared theta together here. That would just mean subtracting cosine squared from both sides. And yes, I know I'm supposed to write theta, but I'm scrunching up the room here. So this means that sine squared theta is equal to 1 minus cosine squared theta. Well, I have 1 minus cosine squared theta. I'm going to switch it out for this sine squared theta. That's how I got this last step that I've written here. Now, where do we go from here? Well, if you notice, that second side was all split up. It looked really long and complicated, and if I remember my rules for logs, it's the same as the exponent rules. If I'm dividing, that's the same thing if you've got exponents and you divide, it's the same thing as subtracting the exponents. And so one of the log rules says that that's what I can do. I can say that's ln of 1 minus cosine theta minus ln of sine squared theta. Okay? So you're going to be surprised at how fast this goes once we actually pick the right place to start, which is why I think identities can be very frustrating. If you've got ln 1 minus cosine theta, hey, if you look at what we got this right here, and that's matching up with what I want here. Now they have minus 2 ln sine theta. So what happened with that? Well, if you remember, you can take an exponent of 2. I could have had it written on the outside of the parentheses over here. Had I had it that way, it would be easier to see that you're going to drop, one of the log rules is the power rule, lets you drop that out front. So what I'm going to do to get my answer, and I'll write it in black just to show you that we're where we started up here, or it matches the right-hand side of where we started. I have ln of 1 minus cosine theta. I have that in my answer, so I'm definitely going to keep that and not try to mess with it. Minus, now that square that was on the sign is going to come out front, and it's minus 2 ln sine theta. And that's how they got it. I just tried to start with the more complicated side, thinking it would be easier. And in this case, it still was good to start with the left side because of all the log rules we had, and I just totally forgot about that. So that's how you would work this one out. If you're watching the video, could not save the other video. It just, something messed up on it, and I couldn't ever even get it to save to my iPad, so it's kind of gone forever. And this is how we would do it. Okay, problem for you. Let's look at 85. 85 says, in exercises 85 and 86, which we're just doing 85, explain why the equation is not an identity and find one value of the variable for which the equation is not true. So the square root of tangent squared x is equal to tangent x. Okay, here's the problem with this. If I had, let's say that tangent x was equal to negative 1. Let's see if we can figure out where, you know where we might could find this is in a 45, 45, 90 triangle. And so let me make one that would have a negative tangent. So let me kind of figure out where I could put it. All students take calculus. So the tangent would be negative, let's say over here in quadrant 2. So I'm going to make a 45, 45, 90 over in quadrant 2. And if I label it, across from 45 would be A, across from this other 45 would be A, and the hypotenuse across from the right angle would be A square roots of 2. Okay, so if I wanted to do the tangent is the sine over the cosine. Well, if you look at, actually I don't have to do that, do I? If I want the tangent of this angle over here, which is really 135 degrees, it has a reference angle of 45 degrees, but if you took and subtracted it from 180 to find out what angle it really is, it's really 135 degrees, okay? So, we'll choose I could, if I want the tangent of that angle right there, I could say it's the opposite over the adjacent. So that would be A over A. But in this quadrant, isn't tangent negative? So let me put a negative on it. So I could put the 1s on here because the A's are going to cancel out. And when the A's cancel out, I'm left with negative 1 over 1, which is negative 1. So let's say I were to look at this tangent of 135. It is negative 1. But what would happen if I put the square root of tangent squared x? Okay. Well, if I took this negative 1 and I squared it, I'd get the square root of 1. And when they don't put the plus or minus in front of it for you, in Trig, you're not allowed to do that unless you're, doing something like we did a while ago where we were trying to look at a certain angle in a certain quadrant. So when I take the square root of 1, I would just write down 1 here because I wasn't the one that came up with this problem. Somebody else did. Had I come up with it, I could have put a plus or minus up here in front of tangent x, and it would be true all the time if I put a plus or, well, I can't put a plus or minus because it's one or the other, right? So it's like I really don't know what I'm going to get there. I could get a positive, I could get a negative. It's not going to be both, so I can't use that symbol even. So that's the problem here. The tangent of 135 is negative 1, but the square root of tangent 135 squared would be the square root of, we found the tangent was negative 1 squared, which would be the square root of 1, which is 1. Since I can't do the plus or minus, I just have to say it's 1. Well, that's not true, is it? Because -1 up here is not equal to +1. So that's not true for all values of x. And here's a case of one where it would not be true.